Welcome back. In this episode, we're going to be looking at properties of matter. It doesn't matter, there's no pun intended with that, that just kind of happened. So, whether or not it's made of glass, our friend Thomas the Train, we've got some metal here, some plastic. I think part of this is wood, or whether it's a block of wood like this, whether or not it's our friend here, Bos Taurus, scientific name for a cow. It doesn't matter. All matter has certain types of properties. There are physical properties, chemical properties, and there's ways that we can test for those. So let's jump into the video and take a look how to do that. It's a pretty hard table. This is a hammer. This property right here, it's not messing with it. If this was glass, it'd probably be shattering everywhere. So something simple, physical property of matter, how hard the matter is. This is kind of simple. This is just a mass, not a weight, it's a mass. And you see I'm just sitting here picking this thing up. And if you look at the rubber band looks like it's stretching out just a little bit, right? Well, this thing right here, I mean, that's not a lot of mass, right? It's a very small mass. Right here, here's a 200 gram mass. So watch the rubber band, and it looks like that rubber band keeps stretching and stretching and stretching, and this thing still hasn't lifted off the ground yet. Keep stretching, now it's finally off. But you'll notice that there's more of a stretch to this rubber band than there was when it was pulling up this mass. This is the physical property of elasticity. So matter has an elasticity. This property is very, very important. If you think about it, your skin is elastic, and as you age, it becomes less elastic. You have like collagen in there. You have all these proteins and sugars and lipid molecules that bind together to kind of help keep the skin kind of together, kind of elastic, because it stretches. As you move around, your skin stretches. This is a very important property of matter. All right, so now let's take a look at this. Pulling on this rubber band, this mass, it still hasn't moved. 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 Now it finally moves. Finally moves. Finally moves. All right. Finally moves. That's stretched out quite a bit. I mean, we could do. This is just all qualitative, right? This is just all qualitative kind of observations. You see, it's a greater stretch makes sense. Greater amount of mass. So there had to be a greater amount of force, but the elasticity of this thing, this is a pretty elastic material if it can withstand this. This is 500 grams, so this is 2.5 times the mass of this one. And so it'd be interesting to see, what the difference in the ratio of the length of this material compared to this one. There's all sorts of things we could do. But eventually there would be mass added to this where the material here, this rubber band is made out of, it would reach a threshold where it could not support the weight of this mass object. So weight is a force pulling downward, just like gravity, right? So the weight of this thing is what's pulling it towards center mass of the planet, right? Gravity. So there comes a point where we would add more mass on this than the elastic nature of this material, this substance can withstand, and it would break, it would snap. At that point, it has reached its tensile point. It's the tensile strength that it has. So think about it. Fishing line, we used different, what we call different weight fishing line that can withstand a greater pull or a less pull. So that if you're going fishing for some minnows, you don't need very strong line. But if you're going for a shark, you're going to need a strong line, something that has a great tensile strength, right? It doesn't have a whole lot of elasticity to it. You want something with greater tensile strength, right? So it's another physical property. Let's get some fire going. Fire. Something so simple, so powerful. The fact that human beings were able to somehow harness this, it was revolutionary. It is one of the effects of manipulation of matter, of releasing energy in a way, and by controlling that release of energy, we've been able to basically move civilizations forward in ways that would be unimaginable without it. Right? Now, it's a little hard to see this. Let me lower the lights just a little bit so we can take a better look. So you can see, got this blue flame a little bit. We move it this way. There we go. Now Marco's tie in the back is helping. And you can see this flame, it has different colors. So that the center area right in that you see, it looks like a flame on the inside surrounded by this larger flame. There's actually different layers. And so depending on where you're at, it's a different amount of heat. This Bunsen burner here, this Tyrrell burner here, or Bunsen burner, we'll be using things like this in the lab quite often. We're going to use a lot of fire. Fire's fun. We're going to use a lot of fire. But while we're here, let's take a look at what this stuff can do. Well, obviously this is made of metal. It's very similar to that hammer. So you see here that this round object here, this round piece of metal, same substance right here, all right, and that fits into there, fantastic, all right. So I don't know. We just have to ask ourselves, what would happen if all of a sudden we decided to heat this thing up? Just gonna let it sit there for a while. We'll come back to it later. Let's let that heat up. Let's take a look at something else. So right here, you can see. Let me come up closer too for you. And I'm being very careful here. Don't do this at home. So right here, you can see that there is this powder. Probably help if I turn on the lights for you just a little bit, huh? So I've got this large watch glass. It's called a watch glass because you could put this over a large container and you literally can see through it. And it's got a concave and a convex side, and so it's basically a large lens. And what it allows us to do is literally to watch through the glass to make observations about things that are happening inside of like a beaker or something like that, or a large, some kind of large container. Just it protects us, but at the same time allows us to make these visual observations. You look at this. This is a very fine powder. It's yellow. There's another physical substance or property. It's color, right? But this is a very fine, solid substance. So the question is what kind of fun is that? For that, you need to turn these lights off again. Let's take a little bit of this. I'm going to put this off in a kind of a safe distance. And I'm just going to sprinkle a little bit of this. And you can kind of see, obviously it's flammable. There's another property of matter. It's flammability, right? So let's grab a little bit more. Why? Because fire is our friend. So this time what I'm going to do is I'm going to just tap a little bit. And let's make some good observations about what's happening here. You see all those little tiny sizzling sparks? So what was causing that instead of this large flash of flame? Let's think about that for a second. We've got this fine powder, all these tiny little grains that are falling down. As those little tiny grains spread apart, each of those little grains catches fire, right? If they're more clumped together, then you get a huge, big spark all clumped together that we would look at and call it a flame. But when all those little particles are spread out, like in the air, kind of like dust, then each of those little particles we can see catching fire, and it looks like a little spark, like a sparkler, right? Like 4th of July sparklers type stuff, like fireworks, right? So that's an easy observation to make. So that has everything to do. So when it's more clumped together versus not, we're talking about surface area, right? And so all those little pieces help provide more surface area, where if it was just one big clump, there would be less surface area for the heat to touch. It would literally just be touching the outside, but not the inside particles. This way, as a powder, as it spreads out, there's more surface area that is coming into contact with the flame, and therefore we see all those tiny little sparks. This stuff here is called lycopodium. It's actually basically it's basically pollen, is what it is. Extremely flammable, as you can see. You want to do something? let's take a look at exactly how flammable this stuff can be. I was not standing right here when that happened, otherwise I'd be bald. I would have no hair. But you can see that when a whole bunch of that lycopodium was pushed through at one time, right? So this is all I did. This basically took a funnel and a hose, made my own little makeshift sort of, I don't know, way of accelerating all of that lycopodium at a really fast rate. All I did was take it away and push it. I created like a windstorm, basically. Pushed all that stuff right into the flame. We saw the magic happen. So this thing has been out of the flame for a while. Let's take a look at what in the world's happened. Earlier, this thing fell right through. I took it out of the flame just a little while ago, and now it's stuck. Well, why in the world is this thing stuck? Well, let's think about this for a second. Before I put it in the flame, all of this substance, this metal, it was at room temperature. Once I put it in the flame, and this round ball right here on this part, as it heated up, what did it do? It expanded. Because typically when matter heats up, the molecules move faster. We call that kinetic theory of matter. And as that substance moves at a faster rate, as those particles, as those atoms, as all the little pieces and parts that are sort of bonded together in different ways begin to heat up, they expand and go further apart. And you know this as solid, liquid, gas, plasma, right? And you can see it at home on every single day things you use. You got some cold butter, it doesn't spread very well. It's it's hard, it's all together. You let it set at room temperature, and suddenly becomes softer, it will spread. It's absorbed more of the ambient heat, and the temperature of the substance has increased. The particles have moved a little further apart. Now all of a sudden, as those particles go from being sort of solid to being less solid, now those particles can begin to move around each other. And we observe that as, oh wow, this butter is spreading very nicely. Oh look, that ice cube, it's now flowing around itself. The water is flowing now. It's liquid instead of a solid ice cube. Heats up, particles go across, now all of a sudden those water molecules can flow around each other. We just say, oh, look at the water. And of course, if you heat it up and get steam, we just call it water vapor. Those molecules at that point are really far apart and moving really, 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 really fast. Speaking of water, you can't see this, but on here is a very clear liquid. All right? Let me turn on some lights to see if I can get a better picture of this for you. If you look closely right here, you can see that there is a clear liquid on this. Well, the question is what kind of liquid is this? It looks like water, but we know in a lab or in real life, if you come across a clear liquid, don't assume it's water and drink it or put your finger in it or whatever the case may be. So obviously there's tests that we could do. If this were water, we know that, well, it would freeze. If we put it in a freezer, it would freeze. If it's not water, it might freeze. Maybe it takes a little more. Maybe you put it in the freezer at the same time as you put water, and you notice, wow, this stuff doesn't freeze, but the water froze in ice cubes very quickly. That will let you know this is not water. And then there's another, well, more fun way to figure out what this is. That's not water. Obviously, this is a flammable liquid. All right, let me go put this up. Be right back. Obviously, this is a flammable liquid. What this is, you probably could have guessed. I just grabbed some rubbing alcohol. So we know alcohols are flammable. Lots of things are flammable. So most solvents that you will see or will use in lab, but many of them, they tend to be very, very clear. The ones that are colored, we'll learn about that later in the semester once we start looking at things with the periodic table and we start looking at specific substances, particularly metals. That's when you can get different colors to your solutions, to things, to solvents that you might see. And we'll detail that later on. But that's not water, but it is mesmerizing. There's just something quiet and peaceful about the flame. I love it. We still got to figure out what's going on with this thing. Sitting here, right? Looks like it's gotten a little bit lower. Wonder why. I don't know, is this thing ever going to do anything different? Huh. Still stuck. I didn't pull that through. Notice now, see how easily that comes out? So what happened? We'll have obviously the opposite, right? Took a while. I just let this thing cool off while I was doing all this other fun stuff with the fire and the hammer and everything else. So obviously this material here, as it was cooling down, the particles, the substances, whatever this is made out of, they came closer and closer and closer and closer together. And as those particles came closer and closer together, they took up less volume of space, which was then less than what this entrance was to that ring, and it fell through. Pretty simple observation, not too bad. But again, this right here, we call this whole concept, remember, thermal expansion. All right, thermal expansion. So as it cooled off, instead of expanding, it was thermal contraction. I guess we could call it that. But typically you just talk about it as the concept of thermal expansion, that when matter is heated up, it typically expands. Every once in a while you run into an exception, and we will look at that later in the semester. It's going to be very important that we understand when and why thermal expansion occurs normally like this, normally, or what causes it to not expand if it heats up, what causes it to contract. Sometimes that happens, and that is a very important property. We'll talk about that later. I hope this helped. It was good seeing you. Come back to lab later and we're going to learn some more stuff. Bye. So that's it. Matter. A lot of crazy stuff about it. There's a variety of physical chemical properties. You're familiar with this stuff. We'll be experimenting with those types of things in class. We'll be burning stuff up. We'll get a chance to look at all the physical and chemical properties. It can be quite fun. So it doesn't matter if it's our friend here, Thomas Train, or if you just want to play a game of marbles, or you have a friend from your Bovidae family that's hanging out with you. All matter just simply has certain properties. And by testing those properties, even if we don't know what the object is, if we look at it and it could just be a lump of something, we can figure out what it is based off of those physical or chemical properties and some tests that we do. That's what we're going to do in class. It was good seeing you again. Good talking with you. Whatever you do, keep being curious. All right? I'll talk to you later. I agree. Bye.